Hello students, so today in this video I will explain you this question which was asked in class 12th physics board exam in 2022. So let's start. The question says define the term distance of closest approach and how will it be affected for an alpha particle if kinetic energy of the particle is doubled. So if you remember, Rutherford performed alpha scattering experiment, or we also call it helium nucleus impingement experiment, and this experiment was conducted to know the structure of atom. And Rutherford took a very thin gold foil and he bombarded it with alpha particles, and on the pattern alpha particles follow after passing through this gold foil, he gave some inferences about the structure of atom. So this term distance of closest approach is related to that experiment only. So we will see what is distance of closest approach. So suppose we have the nucleus of an element. Suppose we have an atom and this is the nucleus of that atom. And as you know, the atom is made up of nucleons, which we call protons and neutrons. So multiple protons and neutrons are present inside the nucleus. So this is our nucleus. So in alpha scattering experiment, this was the gold nucleus. And suppose we throw a alpha particle towards this. So suppose we have this small particle. This is our alpha particle. And if you know what is alpha particle is nothing but a helium nucleus. So if you know helium atom, let's see what is helium atom. Helium atom has a nucleus where two protons and two neutrons are present, and outside there is an electron orbit where two electrons are also present. So this is the structure of helium atom, but if you want helium nucleus, then you need to remove these two electrons. And what will be left with? That will be your helium nucleus. So basically helium nucleus has 2 proton plus 2 neutron in it, and because of the presence of 2 protons it will have a plus 2 charge. So this alpha particle, or we call it helium nucleus also, so this will have plus 2e charge. And suppose the atomic number of this element, suppose it is gold or it can be any other element, suppose the atomic number of this element is G or Z, then charge on this nucleus will be plus Ze or plus Ge. Now let us see, suppose this alpha particle is thrown with a kinetic energy K towards this nucleus, then what is distance of closest approach? Because this alpha particle and this nucleus both have positive charges, so they will repel each other. So when alpha particle will approach the nucleus, its kinetic energy will be decreasing because of the repulsion. It will keep on being slowed down, and at a certain distance after reaching close to nucleus it will stop. So this distance maximum approach the alpha particle can towards the nucleus. So this distance between the center of this nucleus, atom nucleus or gold nucleus, and this alpha particle, this distance we call as the distance of closest approach. So let us see, this is d naught. This is distance of closest approach. So this is the small, what is this? How can we define this distance of closest approach? This is your smallest distance between alpha particle, or it can be any other particle if the experiment involves that. It is the smallest distance between alpha particle and the nucleus of another element taken in alpha scattering experiment. So this is the distance of closest approach. You got the idea. So at this distance of closest approach, when the alpha particle has approached to the closest to the nucleus, this distance at d naught, its kinetic energy will become 0. So at this point all of the energy of the system will be stored in the form of potential energy. So at this approach distance, maximum closest approach distance, the potential energy will become maximum and kinetic energy will be zero. But initially because this initial separation is much higher, so initially we will take initial potential energy as zero, and all the energy was stored in the form of potential energy initially. So now what will we do? We will apply energy conservation. Which energy conservation? It is basically mechanical energy conservation. So let's apply it. So total initial kinetic plus potential energy is equal to final kinetic plus potential energy. Let's put the values. Initial kinetic energy is K plus, because the distance is very large initially, so it will be almost zero, because if you remember the potential energy formula 1 upon 4 pi epsilon naught Q1 Q2 divided by R. So if R is very large, orders of meters, that Q1 Q2 charges are so small, and so that energy will taken be zero. And this is equal to final kinetic energy will become zero, because at the closest approach the alpha particle stops momentarily, and now it will, after this it will retrace its path, so it will go back. So at this closest approach distance, kinetic energy becomes zero, plus what will be potential energy at this separation? That will be using the formula for potential energy of two point charges, 1 upon 4 pi epsilon naught Q1 Q2 upon R. So what is Q1 here? Plus 2e charge of alpha particle. What is Q2? Plus Ze of the gold nucleus or any other element, divided by distance. This distance is d naught we are saying. So from here you have distance of closest approach d naught is equal to, this will be your 2Ze square in numerator, and this divided by 4 pi epsilon naught, and it will be your K here, right? So you can see that distance of closest approach is inversely proportional to kinetic energy. So d naught is inversely proportional to K. So if you increase the kinetic energy, the distance of closest approach will decrease, and if you decrease the kinetic energy, distance of closest approach will increase. So it is intuitive also. If you throw the alpha particle with very large kinetic energy, it will go up to the maximum distance, so it will approach the nucleus to very small distance, and when you throw the particle with a smaller kinetic energy, it won't be able to reach very close to the nucleus, and then distance of closest approach will be large. Okay, so what is the second part of the question? How will it be affected for an alpha particle if kinetic energy of the particle is doubled? So what will you say? If K is doubled, then what will happen? Distance of closest approach d naught will become half, right? So we are getting this from here. So I hope you understood what is distance of closest approach and how it will be affected with the varying kinetic energy of the alpha particle. So okay, so this was the question and this was the answer. So thank you very much. Take care and bye bye.